This is 12.3 Ed Puzzle lesson. We are talking about our solar system and our planets. So our solar system, it includes our sun, the planets and their moons, as well as some dwarf planets, asteroids, comets, and meteors. It is called our solar system because the area of space in where the sun's gravity is most dominant. So the sun being solar.
All right, so in our solar system, we have two categories of planets. Our inner planets are in the category of terrestrial, and that means that they are primarily rocky or mineral based. And then our outer planets are in the category of giants. They're either gas giants, we have two of those, or they're ice giants, and we have two of those. So our inner planets, as I mentioned, are terrestrial, and they typically are going to be smaller. They'll have very few or maybe no moons at all, so no satellites that are revolving around them. They tend to rotate pretty slow on average, and they tend to be very dense. So that's your Mercury, Venus, Earth, and Mars. All right, those are your terrestrial inner planets. And then the outer planets, those gas or ice giants, typically are made of hydrogen gas and helium gas with a few other gases and compounds sprinkled in, and they are not solid. So most likely they do not have a solid crust surface like we see on the inner planets. They tend to be extremely large and have lots and lots of moons, so lots of objects acting as natural satellites. They tend to rotate very, very fast, and then they tend to have much lower density, and that's because they are gaseous. So they're going to have molecules spread out. So there's your Jupiter, Saturn, Uranus, and Neptune in that category.
All right, so the first one is Mercury. That is the one that is the closest to the sun. It has a metallic core, and that surface has been battered by meteor collision. And you can kind of see that there on those pictures, those nice close-up ones that Ms. Laporte's pointing to, as well as those further away pictures. You can definitely see those indentations even from a farther away picture. Mercury doesn't have any moons, and it has a very, very thin atmosphere. The temperatures on there is something kind of crazy as well. During the day, it can get super, super hot. So about 430 degrees Celsius, which you can see there is 800 degrees Fahrenheit, and then can get as cold as into the negatives, negative 290 degrees Fahrenheit. So that range in temperature is quite drastic.
All right, and as we know, temperature is often related to atmosphere. So while Mercury doesn't have a very good atmosphere, like Ms. Kay said, it's very thin. Venus, on the other hand, has a super thick atmosphere. So we're going to see a significant difference in temperature here. So Venus is the second planet from the sun. It has a couple of cool, interesting features. It is a very slow rotator, all right, actually the slowest in our solar system. One day on Venus takes about 243 Earth days, one day. All right, so really slow. And it rotates in what's called retrograde or backwards. All right, so obviously we're kind of a east-west. They're going to go west to east in terms of rotation. It gets super hot on this planet, all right, 900 degrees Fahrenheit. So even though it's not the closest planet to the sun, its surface temperatures will be much higher than Mercury on average. And that's due to its very thick and very toxic atmosphere. All right, you can see cloudy little Venus right here. Got lots of carbon dioxide gas, all right, those greenhouse gases that we talked about, very, very thick, insulating to the max and trapping in a lot of heat that it receives, as well as sulfuric acid and super, super, super fast hurricane level winds on that planet.
All right, our home sweet home here, Earth. It is our Goldilocks of our planet here, so we think we're just far enough away from Earth or from the sun. We do have a metal core. Our surface is dynamic, right? We know about our plate tectonics happening there. We only have one moon. Because of our axial tilt, we have seasons, which we've talked about, and it's mostly covered in water.
All right, and the last of the terrestrial planets is Mars. And obviously, we've been hearing a lot about Mars recently because Mars Mission 2020 has got our rovers there right now. Again, there have been rovers there before. You can see some really cool images of this planet, the ones that have like the little blackout sections, and then the little selfie down here taken by the actual rovers that have been on this planet. So very similar in a lot of ways to Earth. You can take a look in terms of its rotational speed is very close to ours. But as we move further and further away from the sun, you'll notice that the time it takes to go around the sun, in other words, the length of 1 year, is going to start to increase significantly. So our days are 365, right, to go around the sun. On Mars, it takes 687. Mars is the red planet. Why? Because its soil has a lot of iron in it, and that iron has been oxidized. So think about like leaving your bike out in the rain and it rusting. It's kind of how Mars's surface is. It has kind of rusted, it's oxidized, and so it has that reddish tint. It's actually really cold though on Mars, even though it looks, you know, like it's going to be warm. And it's cold because it lost its atmosphere due to solar winds and radiation coming out from the sun and destroying its magnetic field. That's something that protects the atmosphere and keeps those gases in the planet. And Mars lost most of it because its magnetic field was destroyed by the sun. So the temperatures on the surface, here you can see, are typically averaging in the negatives, all right, about negative 67 degrees Fahrenheit on average. But Mars does have 2 moons, which is fairly unique for a inner planet.
All right, next you will encounter the asteroid belt. This is where you will see asteroids that orbit the sun, but they are too small to be considered planet. Tens of thousands of them are located in this main asteroid belt, and it is between Mars and Jupiter.
All right, so we head into, as we move further and further away from the sun, we head into the gas giants here and the ice giants. So Jupiter is the largest of our planets, a beautiful planet in my opinion. You can see one of its moons in comparison to its size. You can see the great red spot over here, as well as down here, which I'll talk about in a minute. And then you can see some of the swirling storms going on this planet. So it rotates pretty fast, all right? 1 day, so to speak, takes about 10 hours, but its year lasts about 12 Earth years. And this is a gas giant, meaning that there's probably no surface. It is primarily hydrogen and helium. It most likely has a solid inner core though, and because it's so massive, its core alone is probably as big as our planet Earth, which is crazy. Cold here as well, very, very cold indeed. That great red spot basically is high level, almost hurricane, tornado level winds, greater than any speed we've ever seen on our planet, happening on in that area that we see that great red spot, right? Numerous moons. The gravity on Jupiter is, I want to say, in the upper 20s, 28 meters per second squared. So if we were to go into that atmosphere or even close to it, we would be sucked in and crushed from the pressure. So a truly massive, a truly king of the planets for sure.
All right, and we have Saturn. Saturn's 1 day is equal to 10.7 hours, but it takes 29 Earth years to make 1 year there. So that amount of time to rotate around the sun there. The temperature here again is very cold, negative 280 degrees. It has 53 moons, so lots and lots of moons there. And it has a 7-ring system. Remember, we talked about those rings not being necessarily real rings, but those are made up of actual rock and ice. They can vary in size. Those rocks and ice can be very, very microscopic, and they can get as big as a house.
All right, to the ice giants we go, further and further away from the sun. The next planet is Uranus, and it's one of my faves because it's the Sidewinder. It also has a retrograde rotation, so like Venus, it's going west to east, so it's rotation direction, but it's also on its side. It's literally rotating on its side, like it tipped over and is spinning there. Lots of hypotheses for that we can talk in class about. We are way, way, way far away from the sun right now, okay? 2.9 billion kilometers, so that makes it 84 Earth years to be able to do one revolution around the sun. So let's talk about this ice giant situation. Basically, there's a small rocky core in the center, but for the most part, you have dense icy material, but because of some of the pressure, you're going to end up with hot methane or hot ammonia in some of that icy mess, which is very interesting. For sure, water as well. We can see methane gas here, CH4 is present in addition to hydrogen and helium. And it also has rings, similar to Saturn, nowhere as beautiful or as thick, but it also has a series of very thin rings that sit around this planet. And you can see some really cool images of this kind of goofy sidewinding planet.
All right, and then we have Neptune, our blue planet. It is the farthest from our sun as far as our planets go. It has 13 moons, and there are actually 6 faint rings here for Neptune. Again, those days versus the years there in comparison with us here on Earth. It is also an ice giant that has a small rocky core.
All right, past our planet, so past Neptune, we enter into this space called the Kuiper Belt. And basically, this is a section, and so, here's our solar system. So obviously, sun in the center, here's, our extremity of our planets. And then we get into this, this region past our planets, and that contains numerous fun little things like dwarf planets. So this is where Pluto is located, as well as Ceres and numerous others. Tons and tons and thousands upon thousands of icy bodies. So things that if they come closer to the sun would be considered comets. Rocky bodies, other probably asteroids of some kind. What we refer to them as are KBOs, all right, or Kuiper Belt objects. And the New Horizons probe that went and took a look at Pluto, and where we got all the really cool images of Pluto recently, also encountered on January 1st, 2019, Ultima Thule, which is this little fella over here. And that was our first Kuiper Belt object past Pluto that we got a really good look at. Most likely, there's probably another planet out there, maybe a planet number 9 that meets some of the characteristics of a planet, because scientists have observed some characteristics of satellite objects in that area. And again, those orbits of some of those KBOs might indicate that there is another planet out there yet to be discovered, maybe by New Horizons as it makes its way through the Kuiper Belt.
All right, and last we wanted to touch base on Pluto. It is a dwarf planet. It is 5.8 billion kilometers from the sun. So I think that's a pretty significant amount of distance there. It does have glaciers, mountains and valleys, plains and craters. It orbits is elliptical, and it is also tilted. Those temperatures again are very cold, and that is due to its thin atmosphere that it has. It has 5 moons for this dwarf planet.